Reference angles. With the calculator, it's easy to calculate the value of sine, cosine, and tangent at an angle. As you get more familiar with trigonometry, you will memorize the values of a few angles at the first quadrant, and then it will simplify the calculation of the values of trigonometric functions at any quadrant. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. When we are working with angles greater than 90 degrees, it's helpful to think of how they relate to angles in the first quadrant, acute angles. Given an angle drawn in standard position, except quadrantal angles, a reference angle is an acute angle formed by the terminal side of the given angle and the x-axis. Let's see how it works. Sketch each angle, then find its reference angle. Start by drawing the unit circle. We want to determine the reference angle of 35 degrees. First, we draw the standard angle of 35 degrees. We know that the angle lands on the first quadrant. Now we can determine the reference angle. The reference angle is an acute angle, so 35 degrees is your own reference angle. The angle 35 degrees has a reference angle of 35 degrees. For every positive angle in the first quadrant, the reference angle is the measure of the angle itself. Start by drawing the unit circle. We draw the standard angle of 141 degrees. We know that the angle lands on the second quadrant. Now we can determine the reference angle. The reference angle is the smallest angle that the terminal side of the angle makes with the x-axis. The angle 141 degrees has a reference angle of 39 degrees. Start by drawing the unit circle. Draw the standard angle of 263 degrees. We know that the angle lands on the third quadrant. Now we can determine the reference angle. The reference angle is the smallest angle that the terminal side of the angle makes with the x-axis. The angle 263 degrees has a reference angle of 83 degrees. Start by drawing the unit circle. Draw the standard angle of 319 degrees. We know that the angle lands on the fourth quadrant. Now we can determine the reference angle. The reference angle is the smallest angle that the terminal side of the angle makes with the x-axis. The angle 319 degrees has a reference angle of 41 degrees. Now let's see what we did to get the reference angles for each item. In item A, the reference angle is the own angle because it is in the first quadrant. In item B, the angle lands in the second quadrant. We take the angle and subtract it from 180 degrees. In item C, the angle lands in the third quadrant. We subtract 180 degrees from the angle. In item D, the angle lands in the fourth quadrant. We take the angle and subtract it from 360 degrees. We can summarize all of this in the following table. If the angle is in the quadrant 1, the reference angle is the on angle. If the angle is in the quadrant 2, the reference angle is 180 minus the angle. If the angle is in the quadrant 3, the reference angle is the angle minus 180 degrees. If the angle is in the quadrant 4, the reference angle is 360 degrees minus the angle. After you learned about reference angles, maybe you ask yourself, what is it used for? Well, using reference angles, we can determine the values of cosine, sine, and tangent for any angles found on the unit circle. This is because angles with the same reference angles always have the same values as the trigonometric functions. The sines depend on the quadrant of the original angles. Let's see how it works. Find the value of sine, cosine, and tangent for each given angle. The angle is in the first quadrant, so the reference angle is the on angle. To find the cosine and sine of 30 degrees, we look at the chart below. The sine of 30 degrees is on the y-coordinate, and the cosine of 30 degrees is on the x-coordinate. Obviously, you could use your GDC. To get the tangent, we divide the sine of 30 degrees by cosine of 30 degrees. You should always keep in mind where these values are in the unit circle. Pay attention. The angle is in the second quadrant, so the reference angle is 180 minus the 120. The reference angle is 60 degrees, so we must find the cosine and sine of 60 degrees. The sine of 60 degrees is on the y-coordinate, and the cosine of 60 degrees is on the x-coordinate. But don't forget, in the second quadrant, the sine is positive and the cosine is negative. To get the tangent, we divide the sine of 120 by cosine of 120. You should always keep in mind where these values are in the unit circle. Pay attention. (225 degrees is in the third quadrant, so the reference angle is 225 minus 180. The reference angle is 45 degrees, so we must find the cosine and sine of 45 degrees. The sine of 45 degrees is on the y-coordinate, and the cosine of 45 degrees is on the x-coordinate. But don't forget, in the third quadrant, the sine is negative and the cosine is negative. To get the tangent, we divide the sine by cosine. You should always keep in mind where these values are in the unit circle. (330 is in the fourth quadrant, so the reference angle is 360 minus 330. The reference angle is 30 degrees, so we must find the cosine and sine of 30 degrees. The sine of 30 degrees is on the y-coordinate, and the cosine of 30 degrees is on the x-coordinate. But don't forget, in the fourth quadrant, the sine is negative, and the cosine is positive. To get the tangent, we divide the sine by cosine. You should always keep in mind where these values are in the unit circle. Pay attention. Now let's see what coterminal angles are. Coterminal angles is an important concept in trigonometry because coterminal angles have the same value for the trigonometric functions. Coterminal angles are two angles which, when drawn at the standard position, have the same terminal sides. Let's find an angle that is coterminal with the angle of measure 420 degrees in standard position. First, we draw the angle of measure 420 degrees at the standard position. Now we can subtract 360 degrees from 420 degrees. So 420 degrees and 60 degrees are coterminal angles. Another example. Let's find an angle that is coterminal with the angle of measure 870 degrees in standard position. We can subtract 360 degrees as many times as necessary until we get an angle between 0 and 360 degrees. So 870 degrees and 150 degrees are coterminal angles. There is a more efficient way to find coterminal angles. Divide the angle by 360 degrees, and the remainder will be the coterminal angle we are looking for. Pay attention. Let's see how it works. Find the value of cosine, sine, and tangent for an angle of 1215 degrees. We divide the 1215 degrees by 360 degrees, and the remainder will be the coterminal angle we are looking for. So, cosine, sine, and tangent of 1215 degrees are the same as 135 degrees. 135 degrees is in the second quadrant. The reference angle of 135 degrees is 45 degrees. In the second quadrant, the sine is positive and cosine is negative. Therefore, the tangent is also negative.